I think 50 Cent shoot people.
I haven't got there yet. He's still in jail. I'm at.
All right, we are recording, guys. All right, so number one, calculate the molar mass of those three compounds. H3PO4. This worker's dying already.
That's not good.
C4H9O2 and ammonium sulfate NH4 2SO4. All right. Just go around the room. How many hydrogens do we have there? Got three?
Yeah, we have 3.
We have 3. And each one weighs? 1. Each one weighs 1? Mm-hmm. How many phosphorus do we have?
1.
1. And each one weighs?
31.
31. And then we've got 4 oxygens at 16 each. So at the end of the day, what does this weigh in total?
101.
101 grams per mole. So 3 times 1, 4 times 16 is 64. And that was 3. So there you go. Yeah, hang on. We have an issue here, guys. Got an issue. Not 101 Dalmatians.
Oh, we have an issue.
We have an issue. So 3, we've got 34. These two come to be 34 plus 64 equals 98. 98. We had 3 too many. 3 too many. All right, carbon. 4 times, what's carbon? 12.
You will get
9 times 1. 2 times
16.
16. So we got 32. 9, 48.
And that'll give you
89.
Are we sure this time?
Yes.
All right.
I don't know where.
Yep.
I don't know where math will.
Grams per mole. Grams per mole.
Make sure you
All right.
put the G.
Now, what happens in here? How many nitrogens am I working with?
2. You're working
2?
with 2.
So I've got 2 nitrogens.
2 nitrogen.
And they are how much?
14.
14. So I've got 28 there. How many hydrogens do I have total?
8.
8. They are 1. So that's that part. Let's go ahead and add that up. 36. How many sulfurs?
1.
1 at 32. Oxygens, we have 4 at 16. 32 plus 64. So that gives us 98.
Oh. Yeah, that gives you 98.
98 here, and then finally, what's our 1?
32.
132 grams per mole. All right, very good, very
Everybody
good.
understand that?
Does that follow? Jana, Sam?
I don't think they were paying attention.
No, she's doing it. You're doing good. Isabel, you ready?
Yeah.
All right. Let's get the next one set up. All right, number 2, the mass of, so we've got 7.5 moles of H2O2, and then we've got 0.55 moles of NaCl. All right, what does 1 mole of H2O2, hydrogen peroxide, weigh?
34.
So 1 mole is 34. And so our math is 7.5. We have 7.5 moles times 34, and our final result is
255.
255.
Mhm.
Everyone in agreement there? Isabel?
Yes.
All right. All right. Salt, sodium chloride.
You have 23 for sodium.
58.
Yep, 23. What do we want to use for chlorine?
35.
35. So we are at 58 for 1 mole, but we only have 0.5 point. Wow, I just want to draw that 0. 0.55. So what's our result?
31.9.
30.9. All right, good. All right, so that's number 2. Now, moving into gases at STP. All right, 1 mole of any gas at STP has what volume?
22.4.
22.4 liters. 1 mole. Any gas, standard temperature and pressure. All right, so our first one, we've got 1.5 moles of H2. Second one, 0.35 moles O2. 10.5 moles of CO2. CO2. Now, do I care what the molar masses of those gases are? Negative. Negative. So now it's simply a multiplication problem with these coefficients and our constant. So 1.5 times 22.4 is
33.6.
33.6?
Yes.
33.6. What's my unit? What's my unit
Moles.
for volume? Moles is
Lead.
Oh,
liters.
Liters.
Liters. All right. Moving to the oxygen. 0.35 times 22.4 equals
7.84.
what?
7.84 liters.
7.84 liters. And then finally, 10.5. I got 10.5 moles of that carbon dioxide times 22.4 is 200 what?
35.2.
235.2 liters of gas. All right, so again, 2 and 3, we don't need to know the molar masses. Oh, percent compositions, number 4, one everyone loves to hate. They're just a little tedious. We'll put these up on the board one at a time. All right, so let's start with something simple. CO2, what's my first step?
You want to figure out the molar mass.
You want to figure out the molar mass. So, carbon is 12. Oxygen, we have 2 at 16. So carbon dioxide is 44 grams per mole all day long. That's one you ought to memorize. 300 years from now, you should be able to tell your grandchildren.
300 years.
300 years, yeah, I'm thinking 300. You guys are gonna have like spare parts plugged into your right and left. Keep you going. I got maybe.
Terminator.
The Terminator, yeah. I got maybe 20 years left on the left for shelf life, but you guys,
Shoot.
away you go. All right,
I can't die. I'm immortal.
you are, okay.
Keep thinking that, man.
Keep thinking that, dude. All right, 44 grams per mole. Now we need to set up our ratios. We set up the first one. 12 divided by 44 times 100. So our carbon,
That's tough.
27.27%.
Thank you. What's this math, guys?
27.27%.
27.3%. Okay, and then our oxygen, we keep saying that's our heavyweight. We have 32 over 44 grams per mole.
72.7%.
72.7%, yes. Times 100%, that's grams per mole. And what number do these need to add up to?
100.
100. So if you're in a test, do that check. Anyone taking notes? Everyone's got this. Excellent. Excellent. Now the big one, glucose. Glucose. And so C6, H12O6. What is my what's my total mass of the carbon?
72.
72. 6 times 12. What's my total mass of hydrogen? 12 all day long. What's my total mass of oxygen? 96. So at the end of the day, 1 mole of glucose weighs what? 180 grams per mole. Grams per mole. If you're going in the medical field, you might want to memorize that one. 180 grams per mole. So what are my 3 ratios for C, H, and O?
72, 180, 12 over 180,
72 over 180,
12 over 180,
12 over 180,
96 over 180.
96 over 180. This is all times 100%. All right, so you all who were absent yesterday, so this is how the composition goes. All right, so what are our 3%?
Carbon 40%, nitrogen 6.7.
Oh, hang on, you're going too fast.